So Darryl, I keep seeing these bondable terminals adjacent to the strain gauges. Can you tell me a little bit about the strain relief that's necessary there and why would we do that?
Tom, that's a great question. Typically, what we try to do when we connect between a terminal over to the tabs of the strain gauge is we provide some small loops to connect over. You really don't want to go straight from the terminal to the tabs of the gauge because presumably you're putting it in a higher strain field and that's the primary direction. And if you pull a wire straight from the terminal over to the tabs of the gauge, and as you start to strain it apart, it could tension that little piece of wire. And copper is not that great in fatigue, so if you start tensioning that wire, what you end up with is two pieces of wire rather than one.
Not to mention the soft solder that's on the other end of it.
Right, true. So what we try to do is put a nice little loop transitioning from the bondable terminal over to the tabs of the gauge. Oftentimes we like to shape those with dental picks, trying to avoid creating a small kink in the wire, especially if your application is a little bit more severe. Maybe it's high elongation where you're expecting very high strains, or you're expecting maybe high fatigue. Either one, you need to make sure that you've got the nice smooth transition from the bondable terminal over to the tabs of the gauge.
So it should look like a nice little horseshoe shape.
Exactly. That's a very good analogy. Let me give you a little story. A few years ago, we had a customer that manufactures diesel engines, and they were putting strain gauges on rocker arms. And they were connecting a 26 gauge wire right to the tabs of the gauge. And what they were finding is they got about 200 hours of operation. And they called us and they said, well, what can we do to make this better? And without making any changes to the strain gauge or the wire, we ended up suggesting that they use a bondable terminal and take that 26 gauge wire to the bondable terminal and then create a nice smooth transition from the terminal over to the tabs of the gauge on the rocker arm. And what they found is that they went from about 200 hours of operation all the way up to 1,400 hours just by making that transition and using a nice smooth loop to get from the terminal over to the tabs of the gauge.
So you're not suggesting a 26 gauge piece of wire from the bondable terminal of the gauge. You're taking a much smaller wire.
Exactly. Typically, it's on the order of about a 34, maybe even 36 gauge wire that would go from the terminal over to the tabs of the gauge. And that smaller piece of wire helps to reduce the forces at the terminal, but it also helps to keep the solder connections smaller at the terminal and at the strain gauge as well.
So small solder connections are typically desirable?
Smaller connections are better when you've got extremes. In a typical structural test, it may not make a big difference, but either in high elongation or high fatigue, for sure you want to minimize the size of the connections. Think of it like this. The solder locally reinforces the tab of the gauge, and the more that you do that, the more you decrease its ability to extend to high levels or respond in fatigue. So we try to keep them as small as we can.
So the small solder junction helps to keep the fatigue right there next to the solder junction lower because it's
less reinforcement from the solder.
So if I'm looking for a high elongation or a high fatigue application, a separate bondable terminal and those little jumper or strain relief wires is appropriate.
Absolutely critical, yes.
Thanks, Darryl.
All right, thank you, Tom.